Good morning, everyone, to TANE Symposium and the ribbon portion. Thanks all for coming. I'm looking forward to seeing everyone in hopefully the near future. We ask everyone that's joined us this morning, and thank you all for joining, that you stay on through the whole 2 hours, because we have some gifts and prizes that we plan on giving at the end. We're just going to have some couple good questions for you guys to answer. Let me make some introductions. My name is Kevin Keogh. I'm the regional director, account director for the Northeast. I cover all the way from Massachusetts all the way to Illinois and as far south as West Virginia. Also, there's Jamie Gibson, who will be speaking. He's the vice president of technology, sales engineering, and he's based out of Texas. Elizabeth Page is a vice president of regional sales for the U.S. for the IOC market. She's based out of North Carolina. Greg Zweig will be speaking as well, director of solutions marketing, and he's based here in Massachusetts with me. Jeff Balder, who works side by side with me. He's a senior sales engineer, Cloud and Edge out of North Carolina. And also Jack Breeding, senior sales engineer, Packet Optical, and he's based out of Colorado. Again, all thank you for joining. Hope to see you all very soon. And now I'm going to turn this over to Jamie Gibson. Thanks so much, everyone. Look forward to seeing you.
Thanks, Kevin. And also thank you to all of our participants and welcome. Today we've got a couple different topics that we're going to talk about. We've started with the introductions already. First, I'm going to talk about mitigating illegal robocalls and how to deal with the latest FCC rulings that have come out around that. Then Jeff Bolger is going to talk about Teams direct routing and the opportunity that service providers have to grow revenue by providing interconnects from the Teams to the PSTN. And then finally, Jack will talk about building an IP optical network for the modern world, and we'll wrap it up with Greg Zweig talking about building the next generation central office. So with that, let's get started. So the FCC has been quite busy over the last couple of years with a lot of different rulings that have impacted our business greatly. Going all the way back to 2017, they started allowing network level blocking for calls when service providers determined that they were illegal in the network. Then in June of 2019, they allowed an opt-out program saying that customers can opt out of blocking programs. And then, of course, we had the Stir-Shaken law or the Trace Act to get passed, and then Stir-Shaken mandate from the FCC in June of 2020 that came along. July of that year, they expanded the safe harbor for unintended blocking, because what was happening was service providers were blocking potential calls, and they were afraid they were going to get in trouble for doing so. In September of last year, the FCC granted a 2-year extension for many of you for implementing Stir-Shaken, but they said that service providers with that extension must have an originating Robo mitigation program. And then the last order that we have that came out in December of 2020 mandated that all carriers have an originating mitigation program to prevent illegal robocalls, and that if you do terminating blocking, it's going to require notification. So let's look at that December order in a little more detail. So it goes into effect May 6th, so not too far from now. And it had a couple key provisions in it. First, all voice service providers are required to respond to traceback requests, and they're required to do so in a timely manner. Second, all providers must take steps to mitigate illegal traffic when they're notified by law enforcement or the Enforcement Bureau of the FCC. And third, and probably the most complicated, is service providers must take affirmative, effective measures to prevent new and redoing customers from originating illegal calls on their network. On the terminating side, there was a couple of requirements in place too. And they said that you can block calls if you meet certain criteria, such as using reasonable analytics, managing those analytics with human oversight. If you are blocking calls and it's determined that they're legal, calls, you have to stop blocking them. And of course, you can't discriminate any particular customer or company to target their calls. So in terms of our presentation today, we're really going to focus on what originating providers are going to have to do by May 6th. So if we look at that, oh, I'm sorry, before I jump into that, there are some stages or some parts of the order that will go into effect in January of 2022. And that's really related to the terminating providers. And that's saying that if you do block a call, you're going to have to respond back using a response code of 607 if the user did the blocking, or 608 if the network did the blocking. And then for those that are doing TDM ISIP interconnects, you have to use an ISIP code 21. So we'll probably spend more time later this year on webinars talking about how to set up your network for that ruling. But really today we want to focus on what goes into effect in May. Before I do it, I want to remind somebody of kind of robocalling and how it goes. So I have a little quiz for you, and you just kind of think to yourself. So the first question we have to think about is, are robocalls themselves illegal? And the answer is no. Robocalling is perfectly legitimate, and a lot of valid use cases for it. So the second question, is spoofing illegal? And again, the answer to that question is no. There are perfectly legitimate reasons for spoofing the caller ID. A lot of times call centers make outbound calls on behalf of a doctor's office, or sometimes service providers or enterprises have DIDs from multiple service providers. And so it's a very legitimate use case. How about robocalling with spoofing? That's still not illegal. You're allowed to do that, again, for those call centers. So really, what it's all about is bad intent. If the caller's intent is to defraud somebody, cause harm, or scam them into providing information or other things that they wouldn't ordinarily do, then that spoofing is unlawful. And that comes from the Truth in Caller ID Act. So really, the focus area is what I'm showing here in blue. It's those robocalls that have a bad intent. So why does this matter? Well, first of all, you can't just block all robocalls because they're not all illegal. Second, you can't just block all spoofing because spoofing by itself is not illegal. Really, service providers need to have a much more sophisticated solution to address that problem. All right, so let's look at those requirements in a little more detail. So first, traceback requests. For our customers that have a C15, it's fairly straightforward. How do you prepare for that? Simple. If you have a call history server, you're set. If you don't have a call history server, that's a great addition to your C15. It is a great analysis tool for understanding all of the call traffic that happened in your network. It can store the history of all of the TDM, the SS7, the PRI, the SIP messaging that goes on, along with the AMO billing history. And depending on your size, it can store that data from 6 months up to 10 years. And certainly good practice is to archive that data at a certain interval as well. You can access that data via FTP into the server and perform all kinds of analysis on that. Conforms to a lot of Wireshark standards, so anyone familiar with Wireshark tools can benefit from that. So that's a great way that you will have all the information historically what happened in your network on your C15 if you get a traceback request. For those of you with other soft switch vendor types, they probably have similar type tool sets for doing that same thing. The next thing is taking steps to mitigate known illegal traffic. And this is the requirement that says if the Enforcement Bureau comes to you, or the FBI, or even your state or local law enforcement comes to you and says you are originating traffic on your network that we have found to be illegal because we're getting complaints and we've done research. Well, how do you comply with that? Well, it's pretty easy. You work with the law enforcement agencies. You notify that customer that's generating the illegal traffic. If they won't stop generating the traffic, you just disconnect service for them. And that one's really pretty straightforward too. I think that preventing your existing customers from originating illegal calls is probably the one that requires the most thought and the most work to do. To address this, first of all, you got to know your customer. If somebody calls and signs up for service and they use a credit card that's stolen from some other person, it sounds a little shady. Well, you probably don't want to give them service. The next thing is you got to have a contract with those enterprise customers with language in it that prohibits all forms of mass calling. You don't want to just give everyone the right to generate robocalls on your network. And you probably want to charge a different rate to the customers that do as well. For the customers that do want to be outbound call centers, first of all, do a more detailed background check on them. Do they have a federal tax ID number? Do they have an address that is a physical address, not just a PO box? Once you've verified who they are, establish rate limits for them. How many calls are they allowed to generate? What DID ranges are they allowed to use? And put all of that into that contract with them. And then finally, how do you police both those customers as well as your existing customers? You subscribe to Ribbon's Identity Hub service for reputation scoring. And what that allows you to do is to block known illegal calls. So calls that come off the do not originate list, calls that are using unallocated numbers, using invalid numbers, things like that. We can automatically block those calls. We can also report on the call volumes for all of your customers so that if somebody starts violating that contract with you and starts generating robocall traffic, we'll be able to identify that for you. So a simple call example, again, I'm using a C15 here, but it could be any soft switch that you have in your network. You get a originating call from Mary Jane, and the call comes into your C15. The C15 will just simply send a SIP invite to the Identity Hub reputation scoring service. In this case, it's a good call, so the Identity Hub will respond with a 480 temporarily moved. And what that does is it directs the C15 to route the call out a different trunk group. So the C15 will just do a route advance and now send that call out an ISIP trunk group to Bob. In this case with a bad call, again, the call comes into the C15. The C15 sends that SIP invite to Identity Hub. In this case, Identity Hub has identified that this caller is using a spoofed number and responds with a 608 rejected, and the call goes to treatment. Actually, I think I've messed up the animation with the words. So in the previous slide here with the call going to treatment, that would be the bad use case. Apologize that on the text. So that's the simplified solution if all you want to do is comply with the FCC requirements for originating mitigation. But that's really part of a much larger solution that Ribbon offers, and the entire solution we call Call Trust. It is a single platform and solution to address and mitigate robocalling for both incoming and outgoing calls, and the same solution applies to TDM and SIP networks. So if you look at the other components that we've added in the solution here on the left, you have the C15 that we've used in this example. Some customers have an SBC, others don't. Works equally well with other third-party soft switch solutions. Some customers choose to add our Ribbon Analytics platform. What that does is allow you to send that call data from your CDR records on your soft switches or your SBCs to be analyzed for behavior patterns. This is very useful for detecting fraud in the network. If a customer is typically generating 1 or 2 calls a day or 1 or 2 calls an hour, suddenly starts generating hundreds or thousands of calls. Well, they could be a robocaller, but it also could be that that customer's PBX got hacked and they're generating bad traffic. So that analytics platform can pick up on what's going on in your network and send that information to Identity Hub so that when you're querying that for outbound or terminating calls, you can have more real-time information out of your own network, which is something that the database services can't really do all on their own. Within Identity Hub, we provide a couple different services. We've talked about the reputation scoring, which is screening the calls for known bad actors. But if a call is coming into your network, you don't necessarily know if it's been spoofed or not. So we can import data from third-party analytics, and we do, for known bad callers, whether the numbers have been spoofed or not. We provide Stir Shaken as a service so that when you do have the mandate to implement Stir Shaken, you just send that call to us as well, and we can sign that call for you. So again, Call Trust builds from the basic requirements that the FCC has for originating mitigation all the way to a full comprehensive solution for all the different call types. So to wrap up this part of the presentation, service providers that were fewer than 100,000 lines had an extension for Stir Shaken, a 2-year extension. That's not a get out of jail free card. You still, along with all the other operators, must take reasonable steps to avoid that originating illegal robocall traffic on your network. The FCC hasn't been overly prescriptive on what you must do to mitigate that traffic, but you can't take draconian steps just to block all spoofing or block all robocalling, because that's blocking legitimate traffic that the FCC says you have to let through. So really you need a more sophisticated solution, and it's a kind of a comprehensive approach, starting with knowing your customer, keeping track of the history, and then kind of like a trust but verify by screening the calls that come out of your network. And again, that same solution can start for the originating side and then can be implemented for the terminating side as well. That wraps up this part of the presentation. And at this point, I'm going to hand it over to Jeff Bolger to talk about Call Trust. Let me just talk about Teams routing.
Great. Thank you, Jamie. Appreciate it. Good morning, everybody. Thank you for joining. As Kevin said earlier, where we are on the agenda now, I want to spend a little bit of time talking about Teams direct routing. And, you folks may or may not have heard about it, but you certainly have heard about some things that happened in 2020 that will cause it to be something that you'll probably hear about in 2021. As everybody knows, 2020 was one of those years that were extremely unique, and everybody has heard it. The news, likes to play it up quite a bit. But there's some things that we've seen as a result that have really changed the landscape for communications. And again, this is something that's probably not news to anybody, but it is very important to understand because it's really going to impact how you as a service provider are going to offer services and what your customer base is going to expect from you in terms of the services that you offer. So, things that the pandemic and working from home and, all of that's related to all that have done is really there's been a big move towards cloud services. So, a lot of folks have heard of like Teams, for example, but, the general public is probably not known of Zoom until a year ago. So, these types of cloud services are becoming much more commonly utilized and much more commonly accepted as workers, residential folks, use them. So from a service provider's perspective, moving to the cloud is much more common than it was even 12 months ago. So as a result of that, and with people working remotely and in non-traditional locations and so forth, customers want services to be delivered instantly. So, the days of ordering a box and having it shipped and then waiting a few days to get it set up and then waiting for a PRI to be installed, things like that, especially when you're talking about people that, have to work remotely and it's, I got to work from home tomorrow, or I've got a home-based presentation that needs to be done. Customers of yours want the services to be delivered instantly. So as a way to respond to that, a lot of as-a-service functionalities have been introduced. So, that's kind of an industry term. It's been around for a long time, but one of the things that you'll see is everything now today is as a service, infrastructure as a service, or direct routing as a service, which is what we're going to talk about. And there's benefits to that, certainly, agility, elasticity, and so forth. And what we've seen is in a lot of cases, those qualities actually trump the price. So customers are willing to pay more for those capabilities, or even as a service type function, even if it costs a little more. So that's something to keep in mind as well. And then lastly, this is sort of the beginning, not the end. One of the terms I really don't like is the new normal, right? And one of the things I think you're going to see is not necessarily the new normal, but one of the things that will happen is I think you're going to see a lot of the things that we've seen over the last year in terms of remote working, utilizing of cloud services, and so forth. That's going to continue. So, in that sense, we're sort of at the beginning and not the end. So I think service providers have a really good opportunity to try to capitalize on some of that. So when you look at Teams, for example, one of the things that's kind of a standout from the data that a survey that Ribbon did last year was that Teams is very widely adopted. And when you look at it with Zoom and with Skype for Business, they're sort of the big three. And then below that, you have some other folks that provide different types of unified collaboration services. But, across the board, there's basically a big need for this type of service, number one. And then number two, if you look at the data, Microsoft Teams, Skype for Business, and even to a lesser degree, Zoom, the amount of variation between the size of the business and the need for the functionality doesn't really vary a whole lot. So for example, with Teams, the large enterprises and the small enterprises really differ very little in terms of their use of Teams and their plans for deployment. Now, if you look at Zoom, that's a little bit different. The smaller businesses seem to tend to want to deploy that, whereas the larger businesses don't. But again, even then, the spread of usage is pretty small, only 5% in that case. So, the net result is web collaboration and organizations using web collaboration, not only during the COVID pandemic, but also afterwards. It's a big deal, and we're going to continue to see that. It's going to be utilized. So when you look at Teams directly, the growth has just been phenomenal. And, hopefully you guys have had, if you're not using Teams, you may have had some customers come to you and ask about it, and do you have the ability to support it and so forth. And, if you haven't, you probably will. And this chart sort of shows that between July of 2019 and October of 2020, almost 100 million daily users were added. And I'm sure the number is even larger now since we're, quite a ways past this data. But as you can see, the growth of Teams has been phenomenal, not only during 2020, but even into 2021. And again, that's going to continue. So, being able to address Teams and being able to actually make some revenue from it is really important. And it's something that, you guys should be thinking about as a service provider. So the question then becomes, well, how do I do that? Well, there's a couple different ways to do it. One is looking at what's called direct routing. And that's really going to be the primary way that a service provider like yourself can gain revenue from an enterprise or an organization that uses direct route, or that uses Teams, sorry. You can see there's 3 different types of calling plans that Microsoft supports with Teams. One is a Microsoft calling plan that essentially makes Microsoft the service provider. And that's a fairly small number of people using it for a couple reasons. You know, I've heard that the pricing is pretty expensive when it gets bundled in with the Office 365 pricing. And plus, depending on where you live, there may not be plans available. So by far the biggest implementation has been in using what's called direct routing, and that's essentially the ability for Teams users to bring their own service provider. And what that means is that the enterprise can select you as a service provider to provide PSTN connectivity to the users of Teams in that instance. So Microsoft in that case doesn't have a PSTN presence. They're actually using you as a service provider. So whether they have a PBX already deployed or whether they're just using the service, you have the ability with a couple different configurations to provide that PSTN connectivity for those folks. And then the third one I'll mention a little bit, I won't really dwell on it, but there's a new capability Microsoft has provided called Operator Connect. And Operator Connect really looks to take advantage of the preference for direct routing, but then utilize a more tight integration into the Teams Administration Center. So Microsoft's still not the service provider, but a service provider who does direct routing has to be integrated into the Teams environment a lot more closely to be able to allow efficiencies because of that integration. So that's something to be looking for, and probably a new evolution as time goes on regarding how direct routing is handled. Okay, so we're going to focus on the direct routing part of it. So the question becomes, well, okay, if I'm a service provider, again, how do I make money off of this? Well, okay, you can provide PSTN connectivity, and how do I do that? Well, there's several ways to do it. This is one that a lot of folks deploy. It's using a public cloud deployed SBC for SIP trunking. The key is all of the voice traffic is going to be taken from the Teams environment and sent to the PSTN. So how do you do that? Well, this is IP traffic. You typically have a session border controller somewhere there for the session border control security and all the different functionality that it provides. One of the ways to do it is to deploy an SBC in a cloud like the Amazon cloud or Google or Azure from Microsoft. Those are all valid options for deploying a virtualized SBC. And then from your network, you provide SIP trunks to that SBC to access the Teams traffic that would be coming out. So essentially, it's beneficial because you don't have to provide any hardware. You just manage a virtualized SBC deployment that's sitting in a public cloud. So it's very easy to scale and to set up, and you don't really have to manage any kind of hardware. So it's different in that respect. So that's probably scenario one. Scenario two is one that provides a little more flexibility, and in this particular case, what we're showing is an enterprise SBC that would physically sit typically at the edge of your network or at the enterprise, and again, it's taking traffic from the Teams environment and passing it along to your provider network via SIP trunks to get to the PSTN. The difference is obviously the SBC is sitting at the enterprise, so it's not typically a large deployment. And when I say not a large deployment, meaning it's typically a single tenant, meaning an SBC that can be utilized for that enterprise. But then the flexibility comes in the sense that you have the ability typically to interface different types of traffic or different types of ports on that SBC. So things like contact centers, legacy PBXs that may have PRIs, for example, analog phones with FXO, FXS type circuits, those can all be directly interfaced into the SBC as well and utilized along with the Teams providers or the Teams members. So basically, a lot of times it's used as a hybrid environment. So you can use it as a transition vehicle while everybody is moving towards Teams and maybe away from more of the legacy analog devices. So that's probably, option number 2. And again, these are, SBCs that you can sell and deploy and support if you'd like to, or you can sell to enterprises, for example, and have them do the deployment and the support. But, you certainly at a minimum would be getting revenue from the SIP trunks you'd be selling. The third way is another way that's kind of common. It's what we call our core Sbc deployment, and that's where a service provider would take what we call a core Sbc, or an Sbc sitting in their environment, in their central office or at a data center, for example. And again, SIP trunks would be extended from the Sbc to the Teams environment for traffic to be delivered to the PSTN. The difference here is that because you're using a core SBC that may be used for other things like, access or peering to long distance carriers and so forth, for Teams and direct routing, this SBC can be set up to be in what's called a multi-tenant environment, meaning that you can support multiple enterprises at the same time with that core SBC by having separate tenants set up for each one of them. So obviously you're still getting revenue from the SIP trunks that you're selling. You still have the ability to utilize just a single SBC for multiple different functions and functionalities. So there's lots of efficiency when you're using that SBC that's probably going to be used for other stuff as well. So that's probably the third way to do it. An alternative to this, to take advantage of the as-a-service movement, is a product that Ribbon calls Ribbon Connect. And it's a fairly new product. It went generally available, I think, in January of this year. But it takes advantage of the as-a-service capability that I talked about earlier and applies it to Teams direct routing. So a lot of times you'll hear it as direct routing as a service. And essentially what that is capability that's built into the cloud, and that cloud would include all of the components to be able to connect to the Teams environment. And you, as a service provider or an end user, actually, would basically subscribe to the service and pay a monthly fee on a per seat basis. So it makes it very easy to pay for the services that are being consumed. So since it's a subscription-based service, the service provider can, integrate to it the PSTN just like they would do today, integrate to a legacy PBX if that's a requirement, and provide those services without having to manage the SBCs, without having to worry about licensing, without having to do support, that sort of thing. Ribbon takes care of all that capability. So essentially you sell a service to your Teams customers to allow them to retain the ability to do direct routing. So it's really an efficient way to allow end users to get the best of both worlds, where and yourself as well as a service provider, you get the ability to offer those services without having to make the investments, and you can obviously scale and use this as a starting point, for example, and then maybe when you reach a volume, maybe you want to take the service back and put it on your own SBCs. So, certainly things like that can be done, but it's another option, and certainly probably I would call it maybe option 4 for doing Teams direct routing. So I touched on it a little bit. We all know as service providers, and I think IP has been out along with SIP, those have been out for a long time, and there's a lot of different use cases for SBCs in a service provider's network. So this chart's very busy. It shows a whole lot of functionality that just an SBC in general can be used for. And in the bottom right-hand side, you can see the Teams capability. But what I did want to point out is, again, just sort of a review that, Ribbon has core SBCs that can be used for that multi-tenant capability. The virtual products are what we call our SBC SWE. Those can be deployed in a cloud, or if you need a premise, or if you need a core-based product that's on an appliance, we can offer a 5400 or a 7000 for really large applications. But quite honestly, we've seen most of the demand from our customer space being towards virtualized products, either on regular old COTS hardware or in the cloud. So that's certainly something we've seen a shift in demand for over the last year. But the core SBCs are certified for both Zoom and for Microsoft Teams, so kind of keep that in mind. We have products to meet that, as well as if you look at our larger portfolio that not only includes the core SBCs, but also the enterprise SBCs. We have SBCs that can be deployed on the edge very economically and can be scaled to meet pretty much any kind of customer size. And as well as the service provider edge, we haven't really talked about it, but we have a line of EdgeMark products that some of you have probably heard or hopefully deployed that can also be used for providing various types of functionality right at the service provider's edge. So, the Ribbon commercial here is we've got SBCs for the core, the enterprise edge, and the service provider edge, depending on how you want to deploy and what your solutions are. So I'll kind of wrap up here and go back to Microsoft Teams. Think of Microsoft Teams not necessarily as a competitive threat, but as a revenue opportunity. With direct routing, you guys have the ability to go out and engage these customers, whether it's in your territory or if you're a CLEC and you want to CLEC out to the next town. You can go after some of these enterprises that offer Teams capability and offer direct routing, whether it's based on premise equipment that would be located at their location, in your core, or something in the cloud, or even as a service. It's definitely an opportunity for you to be able to capitalize on the ability to offer SIP trunking to those users. But it also represents cost savings. So, using your SBC for multiple capabilities in a core scenario allows you to, essentially make better use and optimize the products that you would provide. And then, if you're doing a core SBC with multiple tenant, you have the ability to utilize a minimum of IP addresses, even with multiple tenants in place on your SBC. And then that allows you to reduce your operational overhead and costs as you serve, another type of traffic. So really it's something that if you haven't heard about Teams, you probably will in the future. And, rest assured that we do have solutions for you to offer direct routing capabilities to your end customers. Okay, so next on the agenda, I'm going to turn it over to Jack, who's going to talk about our IP optical products.
Thanks, Jeff. Well, good morning, everybody. I will be talking about a new addition to the Ribbon family, relatively new. We've been around, we've been a part of the Ribbon family for a little over a year now. But the equipment, the solutions, and the capabilities that you're going to see in the next few slides are the result of decades of research and development, and are some of the leading solutions around the world, with millions of customers currently operating on them. So this is just an introductory slide. We're going to talk specifically about some examples, some real-world examples using real customers and how they were able to leverage what is typically a cost on the network side into revenue opportunities to reach new customers, to reduce their CapEx spend as well as their OpEx spend. But I wanted to give you this one slide just to kind of reset because we've been talking for a while through Jamie and Jeff's presentations on the voice and the cloud and edge side. So we're shifting gears here now towards your internal network, the pipes and devices and so forth that carry all of that voice traffic, as well as your data and for many of you, video as well. So Apollo, if you look on the left-hand side of the screen, Apollo is the DWDM, the optical transport, the Otn switching. This is the force multiplier, we like to say. It turns your single pair of fiber into as many as 96 different individual virtual pairs of fiber, right? So DWDM is a way to maximize the use of your outside plant. Through other techniques and capabilities within the Apollo family, we're able to extend your reach far beyond where your home service area is and let you go out and visit and provide services to more remote areas. Neptune is moving up in the stack, if you will. Neptune is a layer 2, layer 3 transport switch router. Another way to describe that is a multi-service and multi-layer transport platform. And we're going to talk more about that specifically and where it's most applicable. And I think you'll find that that there is a place for Neptune just about everywhere in your network. And then Lightsoft, we're not going to talk so much about today, but just to let you know, Lightsoft is our current management platform. Everything we make here at the IP Optical group at Ribbon is controlled by Lightsoft. It's a single pane of glass that covers everything. And then to the right is our Muse SDN and orchestration automation platform. This is the future of networking. Many of you, I'm sure, have read about software-defined networking, orchestration, and automation. This is where we are actually able to leverage software to provision services across multiple platforms, even allow customers to pick and choose on a dashboard and allow them to provision their own services. Of course, you're doing the work behind the scenes, but they're making choices, and it's automated behind the scenes with billing and that sort of thing. So that's just to kind of level set where our conversation is going to go within the next several slides. And with that, let's move forward. So this is a Georgia company that was deploying GPON broadband out to residential areas. And as they were deploying it, they were looking for a way to reach the nearest internet peering point for this particular development. The issue, of course, was that in that case, the internet peering point was much further away than they could reach with their existing equipment. So in this case, or with their existing outside plant. So in this case, they formed a partnership with a power company that happened to have the fiber to the internet peering point, and they were able to leverage that agreement along with Apollo amplified signals to provide a very long reach from their plant across the the partner's network all the way to the internet peering point. So we ended up with a pair of Apollos for redundancy's sake, connected to the home network, but able to leverage that long reach amplified 100 gig connection all the way to the core routers and the internet point. So the idea here is that using Apollo, which greatly extends your reach across either your fiber or someone else's that you have an agreement with. It lets you reach out and touch those resources that ordinarily might be too far away. What you'll see with all of our products, be they traditional Apollo transport or Otn switching or our Layer 2 and Layer 3 Neptune solutions, is they're all built carrier class. They're all designed and redundant to support a 5 nines operation. And typically we expect when we put equipment in your network that's going to be there for 10 years or more. So it is a very different model from a number of vendors out there today that that you may see in a competitive fashion. So this is another opportunity, again using the extended reach of an Apollo optical solution. In this case, if you look at the diagram here, on the left-hand side, you've got the home service area of this particular network. They were a rural broadband provider, doing fairly well with about 6,000 subscribers. They have their internet connection. They're providing voice, video, and data. But of course, they were hemmed in by either a lack of fiber plant or by competitors. But the answer in terms of growth, obviously you want to provide growth in your business model and bring in that additional revenue. So they started casting a broader net and looking further away from their home service area. Well, they were able to find resources that fiber resources that gave them about 120 kilometer reach out to another cluster of subscribers. Again, this is in a rural area, so rather than in an urban area where everyone is obviously packed in closely together, these are little clusters of customers, if you will, very common across the United States, right? So what Apollo allowed them to do with an amplified signal is leverage what we call virtual adjacency, right? So by providing that 120 kilometer reach out into this new cluster of potential customers, they were able to bring all of those customers virtually into their home service area, right? And with the right bandwidth and with the right traffic engineering, they are virtually adjacent to the internet connection and to any other resources that the original customers in the home service area have access to, right? Be that content servers or what have you. So the idea is that with the Apollo solution, we can not only extend your reach, but also give you really a massive scalability in terms of the amount of data that you can move, really up to multiple terabit signals. So the other aspect that I'll mention to that is, a lot of times you'll see these massive predictions of bandwidth and so forth that that equipment might be able to support. The goal, though, from our perspective, is that we want to allow you to pay as you grow. So the purpose of an Apollo is certainly to provide that initial reach and then as much bandwidth as you need at the current time, but then to give you that flexibility and that scalability as time goes on to ramp up to meet whatever those needs are, very simply and with minimal investment after the initial build is done. This is another example. This is where in an urban area you might see more of a mesh type network with lots of connections and endpoints and so forth. This one is actually statewide down in Georgia. This particular critical infrastructure company implemented a statewide DWDM solution. DWDM, again, being multiple wavelengths on a single pair of physical fiber. Each one of those wavelengths, of course, can carry, as an example, 10 gig or 100 gig or 200 gig. There are even larger interfaces above that. But the highway, if you will, the network highway was expanded to cover multiple core sites, actually over 24 core sites, as well as hundreds and hundreds of endpoints. So with that virtual adjacency that I mentioned in an earlier slide, what this network is able to do is bring a couple of things, well, actually a few things to bear. The first one is that you've got reach out into multiple underserved areas, in particular in Georgia, out to rural areas that may not have had access to the same sorts of resources that say an Atlanta or a larger city might have. So that's a combination of reach, being able to use an amplified signal to get further down your fiber. It's also the result of the scalability and flexibility to expand those pipes really as big as you need them. We literally can build networks now that are so big that really, to use the final aspect or the final channels in a network, really is, we're not there yet, right? The network is bigger than can possibly be used at this point. So we don't have anybody that has built it out that big, but the technology is there today that allows you to build even a modest start at a network and then know that in the future you can handle anything that comes down the pike. The other thing that this statewide network does, which is really in a larger scale, similar to an urban type network, is that all of those resources from content providing, internet, and voice services and so forth, all of those are now available to everyone across Georgia that is connected to this large network, right? Implied in a design like this is 5 nines of reliability. This network, in fact, is not just sub 50 millisecond failover protected in case of a failure, but this is a self-healing network. So if you get a single failure, then of course it will route around and provide service sub 50 millisecond. If you get a secondary failure, it will accommodate that as well. It will continue to heal itself, failure after failure after failure, even in a cascade scenario, until you literally have, if the scenario is that bad, and fiber is completely cut all the way around the site, then of course it's isolated, right? But the intelligence is built in at layer 1 on this network, without employing routers, without employing switches. This is a layer 1 optical network that will heal itself as negative events occur. Included in this, and I've got a slide on this in particular coming up, is the ability to operate encrypted signals on a per service basis. So in a network like this, you might expect that you've got healthcare customers, you've got government customers, you may even have federal government customers. Certainly across Georgia, you've got multiple military installations. The ability to offer service at a layer 1 level that adds no latency and no overhead, and then provides AES 256 incredibly tough security and encryption is really a benefit. So this is a value add that you can offer your customers. The cards that are available that provide this service can obviously be used without encryption. And then when you have a customer that needs to protect healthcare data or government data or what have you, banking, financial transactions, then you can offer that encryption service to them all the way through your network. They own the keys, so you don't have to be involved in that. And then if somebody does tap into that line, all they get is gibberish, of course, which is the whole point of encryption. So we'll talk more about that in an upcoming slide. And then, of course, in a big area like this, there are multiple data centers, and so that is another value add for a mesh type network like this. where you can sell those services to data centers, geographically redundant data centers, and then provide them that virtual adjacency, right? So on a network like this, we can easily run 100 gig per wavelength, again, up to 96 of those wavelengths. We can run 200 gig in most places, and in many places we can run 400 gig and 600 gig signals across fiber. And this, once you start getting up into the 400 and 600 gig range, you're really talking about data center type throughput. Most providers aren't looking for that these days. Of course, one day it'll happen, just like everything else has in this industry as it's grown. But the ability to provide really anything from T1, quite frankly, transport, all the way up to 600 gig on the line side, that's really what I mean by flexibility and scalability. Okay. So let's talk a little bit about wireless operators. Space is at a premium in your cabinet. Obviously, we've got a number of newer technologies as well as legacy technologies that we need to support these days. Not only is space limited, but of course you pay for power, you pay for cooling, and you pay maintenance on these devices that you put in there. And there are, in many cases, multiple interfaces to control them, which means your techs and your support staff have to know multiple operating systems and have to have, multiple clients on their laptops or on their workstations. So the purpose of this slide is really to say, can I combine many of the tools that I need and many of the services that I need to support on a single platform? Is there anyone out there that makes a device that will cover everything from legacy TDM through IP RAN, carrier Ethernet, and so forth? Can I handle mixed media? What if I have fiber and microwave? So everything really from that layer 2 VPN service all the way through to, if you choose to interface with an MPLS cloud, can I do all of this, but can I do it cost effectively, right? And of course, it's a setup, right? Of course, the answer is yes, you can do that. And the answer that we would provide is what's called our Neptune multi-service transport platform. So this is really the only slide I had that's really all about a box, right? We like to talk about solutions, but the introduction of this box is really an example of many places that this particular device can go. So we've moved from my earlier discussions about layer 1 transport, scalability, flexibility, and amplified reach with the Apollo solution. Now we're talking about our Neptune layer 2 and layer 3 transport capabilities. So what you see on the screen is a Neptune 1300. This is one of 8 different form factors, starting with very small, half a rack width and 1 rack unit high, all the way up to full rack solutions, right? So Neptune 1300 is kind of in the middle. The points I want to make about this, we'll talk a little bit about the capabilities. It is a packet transport. It does support layer 2 and layer 3 VPNs. Everything from layer 2, very simple layer 2 protocols, switching, VLAN tag manipulation, Q and Q operation. We support provider bridging, 8032 ERPS rings, as well as MPLS TP for utterly reliable, very rapid failover from working to protect. All the way up to layer 3 operation, OSPF, BGP, ISIS. If you need a router in your network that supports MPLS operations, segment routing, and can support BGP and OSPF, Neptune 1300 and all the Neptunes can do that as well. The Neptune series is also pre-built and pre-qualified, if you will. It is already ready for 5G operation. For those of you that are in an area where 5G is becoming more of a reality, then some of these terms will be familiar to you. Segment routing, transport engineering, hard slicing, flexible Ethernet, G.MTN. All of these technologies are currently supported in the Neptune platform, so that if you are in a position where you need to support those mission critical 5G applications, then Neptune is ready for you today. It has very stringent timing and synchronization support, not just for traditional Ethernet, but it also supports Class C and then soon to come Class D timing for 5G. Again, that will mean something to those of you that have done your reading or are looking in the near future at deploying 5G. These are much more sensitive and much more stringent timing requirements than are currently required for say LTE. Finally, I mentioned on the previous slide that this supports legacy interfaces. What we do is we support what's called CES, or circuit emulation. That is where we can take anything from a T1 to an OC12 and packetize it, and then multiplex it up with other Ethernet circuits and send it over your network. Excuse me. And then at the other end, we will depacketize it and then hand off those legacy TDM circuits. And the TDM switches on either end of your native Ethernet network think that they're directly connected, right? So there's no interference, if you will, with that legacy circuit. So this is really critical moving forward as TDM vendors, traditional TDM vendors, are decommissioning their platforms. They're being manufactured, discontinued. Support, of course, is eventually going away. However, as we know, in many cases, those legacy SONiC connections, TDM connections, are not going away. I remember 5 years ago we said, well, we'll never use T1s again, right? They're going away so quickly that that they'll just be gone in 5 years. Well, they're still here, right? And those of us that are realists understand that many of those are going to stick around for quite some time. So having a platform that is in the prime of its life cycle, obviously still fully under support. In fact, we're still doing R&D to support new TDM interfaces, what we would call new to us TDM interfaces. There was a great demand for DS3s, and so we're building a DS3 card for this platform so that we can packetize those as well. So this is your on-ramp to decommission those perhaps long out-of-life TDM boxes and support that across your native Ethernet next-gen network today. The red box in the lower right is just kind of a reminder, right? Everything we make here is 5 nines relatable. It is, I should say, redundant. Everything in terms of power supplies, redundant fans, redundant switch matrices, everything we do is designed to keep your network up and running in a 5 nines fashion. All of our software updates are hitless. So there really isn't a situation short of a catastrophic failure of either power or a fire or floods, what have you. There really isn't a situation where these devices are vulnerable. Here's my slide on encryption that I told you about earlier. So this is a provider in Tennessee, and the moral of this story, I'll give you the punchline right at the beginning, is that if you're fiber rich and you don't necessarily need DWDM because you've got plenty of fiber, wouldn't it be great if you could leverage some of that fiber, right, and drive revenue? right? So what this company did was they were approached by a larger organization in Tennessee that were in need of an encrypted 100 gig transport, but all they needed was point to point, right? So really what they needed was an easement through this particular provider's territory, but they needed a very specific requirement. They had A to Z, they had the route all mapped out, they needed encrypted, and they wanted 100 gig, obviously with the capability to expand that in the future. And so what we were able to do was turn up very quickly 2 Apollo devices in a very cost-effective manner, give them a 100 gig through pipe, if you will, through that the Tennessee provider's territory, and then of course turn the encryption on. Now the benefit, of course, is that now you have this Tennessee provider has Apollo shelves operating traffic across strands of their dark fiber, and they're getting an MRC for that, recurring revenue coming in. But then they've also got the Apollo shelves that they can utilize for other resources as well. So this is a kind of a dual example where from a cost-effective standpoint, we can build optical bridges from one part of your network to another without replacing the entire network or without even overlaying any part of your network. And then, of course, the encryption piece is the value add, right, in this particular case. So now we're going to talk about another aspect of the Apollo devices. This is Otn switching. Some of you may be familiar with Otn switching. OTN, I'm sure virtually everyone is familiar with the term OTN, right? Optical Transport Networking. What OTN is, in a nutshell, is an extra encapsulation around your data. If you're moving TDM traffic or if you're moving Ethernet traffic, then OTN is an encapsulation that goes around that payload and around the, for instance, the Ethernet header, and it turns it into an OTN frame. And then you move that OTN frame just like a cargo container, you know, on a rail car, right? You put all your payload inside the container, you move the container, and at the other end, the container's taken off and everything is taken out of that container. That's what OTN means. So virtually every DWDM system out there today uses OTN framing around the payload, and that is simply because OTN provides additional reach through something called forward error correction. Not necessary to know all of the details about that. The point is, in a DWDM system, we use OTN primarily because it gives us additional reach across fiber. So literally, it gives us extra kilometers that we can reach without using amplification. So that's one use of that OTN encapsulation. Another way to use it is in the way that we used to do, well, in many cases we still do, with TDM switching, where TDM, of course, and Sonnet has containers that you put things in, right? An OC48 is nothing more than a 2.5 gig container. There are 4 OC48s in an OC192, which is a 10 gig container. So OTN is very similar to that. In fact, that's where it takes its cue. So there are the smaller containers within the OTN system are called OTUs, say OTU1, OTU2, OTU4. And I don't have a chart for you here. I should probably put that in my next one. But essentially, an OTU2 is the same as an OC192, roughly speaking. Okay, it's about the same size, about 10 gig. Okay, an OTU1 is about the same size as an OC48. So you may ask, well, if I've already got TDM containers, why do I need OTN containers? Well, the benefit is that the OTN containers don't care what's inside of them, right? So an OC48, in order to carry Ethernet over Sonnet, we have to put a lot of overhead on there, and it's very inefficient and wasteful. Same with larger TDM and Sonic containers. OTN was designed to be those, I'll go back to my railroad analogy, OTN was designed to be those containers that you could put anything into very efficiently. And then you can stack them all on the same train or on the same wavelength. So imagine having an OTN container that is full of your Sonnet data. And then the very next one in line is full of native Ethernet data, right? And then the very next one may be all video data. So I can multiplex all of these various signals, gigabit, 1 gigabit Ethernet, 10 gigabit Ethernet, and so forth. I can do fiber channel, I can do Sonnet. There are various video signals that are amenable to OTN encapsulation. And so now I've got a train of cargo containers, and with OTN switching, what I can do is at every location around my network, I can pick and choose which one of those containers I want to take off and which ones I want to leave on the train to go down to the next station. So that's what OTN switching does. I can remove containers at every station, and I can put them back on at any station at an optical level, which means I'm not spending the money for pluggables, for additional cards. It gives me the ability to pass through individual locations and multiplex everything onto a single wavelength. So if you look down at my diagram down at the bottom, this is the schematic of what I've been talking about. So at each one of these locations, we've got an OTN switch. Imagine this as the cargo crane at a train station. And every one of these is able to take containers off and put them back on again. And I'm running a single 100 gig wavelength all the way around, very cost effectively. And then I can backhaul all of that access back to my distribution or to my core, right? So, and keep in mind that even though I've got a single wavelength here, all of my services are isolated in their own fashion and in their own containers so that they don't interfere with each other. And at any point along this operation, I can pull off my Sonnet data, put Sonnet data back on, you name it, right? Whatever I want to do with my Ethernet, my Sonnet, my fiber channel, etc. So this is a technology that's been around for a few years, but OTN switching traditionally was fairly expensive because it was designed for core networks, and so you had half rack and full rack switches, and that's where the OTN switching industry sort of was focusing. Well, now we have devices that will provide this service in a 1RU form factor and very, very cost effectively. So this is a capability that you can use even independent of a larger network that does not have OTN switching on it. Wherever you've got limited fiber resources, typically out in the access, we can give you that 100 gig pipe. You can collect every bit of traffic out there, regardless of the source, and bring it back in for processing very, very effectively. So this is an example of the graph at the top. The graphic at the top shows you that there are typically in an average network, you've got many, many low-speed client interfaces. Let's call them 1 gig and 10 gigs. We can take all of those through our OTN switching matrix and then start filling more efficiently our wavelengths. Now this one has 100 gig, 200 gig, 400 gig, but scale all of these down. Take zeros away from all of these if you've got a smaller operation, and I can take all my OC48s, all my OC12s, all my 1 gigs, and I can fill my 10 gig wavelengths that much more effectively. So that's what this graph in the lower right is indicating. So I've been in the DWDM and transport business for quite some time, and I certainly find this to be true. What you're looking at here with the orange line, with the blue line, is that as you add services, typically what happens is we get requests, we add services, we put them on our DWDM wavelengths, and those wavelengths start incrementing. So I start with one wavelength, I go to 2, 4, 8, 16, or what have you. But I'm not using all of those wavelengths, right? All of those individual wavelengths. So I may turn one up that has a full speed of 10 gig, but the customer's only using 2 gig of it. Well, I have 8 gig of stranded bandwidth there, and I continue to eat up my wavelengths. So wouldn't it be great if I could take advantage of all of that extra space, what we call stranded bandwidth? And then if my network, if each channel is rated for 10 gig or 100 gig, then before I go to wavelength number 2, then I fill that first wavelength all the way to 10 gig or all the way to 100 gig if that's the speed of my network. So that's what this graph is showing, is that the blue line is the more services with a traditional DWDM system, the more channels you start eating up. And of course, the more channels you turn up, the more of those expensive DWDM optics you're buying. So how do we reduce that spend? Otn switching is the answer there, because Otn switching, as I mentioned in the last slide, allows me to combine multiple data sources and put them on a single wavelength. And so the orange line shows you that growth over the same number of services, but we're more efficiently packing those wavelengths. The dotted line is the difference, right? What are the savings, right, between the two? Because I'm getting more out of my investment. If I put a 48 channel or even a 16 channel DWDM filter in, well, how do I avoid having to double that and triple that down the road because I keep eating up my wavelengths? Again, Otn switching, because it makes your existing DWDM system that much more efficient, right? Call it a turbocharger. The bottom line here is that we're saving you CapEx, of course, because you're spending less to transport your data. OpEx as well, because you're becoming more efficient. There's less to keep track of, and then if an issue takes place, then it's much more efficient and more rapid to troubleshoot. So just a couple more slides here. This is another example of an Otn switching application. This is a very large statewide network, 11,000 kilometers of fiber, many core sites. Of course, there are many routers here to handle what routers do, right? And handle that layer 3 processing. So they were looking at upgrading their bandwidth really all the way across the network, from a more of a traditional 10 gig to a 100 gig throughput. So in order to do this, they were going to have to upgrade all the processors in their routers, and you folks know what that means, right? That is a lot of money, right? Router vendors get a lot of money for what they do, and routers, of course, are the big traffic cops, the big processors, very CPU intensive, very memory intensive. So is there a way, they thought, is there a way that we can bring this data to the routers and make it more efficient so that we don't have to continually upgrade our router processors? And so what they ended up doing after they looked at the price tag to upgrade routers was they put an OTN overlay network in. So what this means is OTN switches at virtually all locations to collect the data from the access and distribution, and then create express lanes that bring it into the routers and offload a lot of that switching work from what the routers were having to do. So this is basically letting the OTN network do the heavy lifting of simply moving data from one location to another. Can routers do that? Sure they can, at a premium, right? So typically your layer 3 router ports, your layer 3, your router processors are orders of magnitude more expensive than they are at a layer 2 price. And so we used less expensive resources in terms of Otn switching to efficiently move all that data to the routers, and in the process generated tremendous savings for them. And as you see the tagline at the bottom, right, the amount of money that they saved by not having to upgrade those routers absolutely paid for the Otn network and then some. So this is all, it's scenario dependent, of course, number of routers, but the math can be very compelling in terms of a CapEx spend. So it's certainly something to take a look at because of its ability to cost efficiently collect your data, deliver it, and do that all very efficiently. So this is my my Otdr slide. So this is, we're kind of shifting gears here for this slide. Everybody, of course, is familiar with Otdr technology. It gives you the map of your fiber plant, right? It tells you exactly what's going on a given piece of fiber. So in this particular case, it was a Mississippi-based company. They created a routed Ethernet ring. They did not need DWDM. So it's a very geographically centralized location, but their mission critical data required that they kept very close tabs on how healthy their fiber was. So, you know, typically with Otdr, it means a person in a truck with a handheld meter. They go out, they disconnect the fiber, and so traffic is not flowing. And then they spend time shooting that fiber. Often it's two people in two trucks, one at either end, and they're shooting and then providing those traces at the end. And you reconnect. You have to do this in a maintenance window. You have to shift your traffic to an alternate path. It's a fairly large operation. Not to mention when there's a fiber cut, always at 3 a.m., and you've got to get somebody out of bed, and then you say, well, there's a break. I'm getting loss of signal at either end, and that fiber span is, 75 kilometers long. Well, where's the break? Well, you're not going to know that until you get your Otdr out there, and even then, it may not be exact. So you're trying to figure all this out, and of course, there are issues with your customers. If you've got traffic protected, great, but still, it's a headache. So this solution is an Otdr solution that is built into your optical network. So literally this Otdr shoots every span in your network all the time, 24/7. While your traffic runs, it uses a wavelength that is far enough away from your data transmission wavelength. So with DWDM and most long-haul traffic, it operates around 1550 nanometers. This signal operates at 1610 nanometers. So it is far enough away that it absolutely does not interfere with your current traffic. So you can operate it in service 24/7. It also keeps track of historical traces. So the moment you turn this up, you're getting a birth certificate, if you will, showing you exactly what that fiber looks like with an Otdr trace. Well, then as time goes on, a month, 2 months, a year down the road, it has collected all of that data. And so 6 months from now, you can pull up a current real-time Otdr trace and then compare it to the way things were 6 months ago and see if you are getting any fiber degradation. Of course, it'll show you if there were breaks and you've spliced them, but it will show you before there's an issue, it will show you that degradation has happened over time because you'll see a trend of fiber loss. And that allows you to get out there and do remediation before there's a break, before there's a loss of signal or loss of frame on your endpoint. So this is one of those technologies that we provide that I like to think of as headlights. They're bright headlights way out in front of your pickup truck out on the road. We've all had the experience of driving down that dark road at night, and you've got your headlights on, of course, but then that deer runs out in front of you. Well, this gives you brighter lights in more direction so that you can see that that hazard coming down the road a lot further on and then take remediative action before it becomes an issue. Okay. Otdr is the inline, in-service, and always-on Otdr solution is something that that we provide really almost outside of our traditional Apollo and Neptune devices. This actually can operate over anyone else's optical network. It does not require our network hardware to operate. It generates a signal. We place filters out on the network to route the Otdr signal around nodes, so I don't have to put a card or an Otdr meter, if you will, at every single span. In many cases, I can put one or two of these cards in an entire network and get the whole network. So it can be very cost effective, and the peace of mind that this provides is really invaluable. The last thing I'll mention is just a quick anecdote. We have a very large customer with thousands of kilometers of fiber down in the south, and they have this system in place. And sure enough, at 2 or 3 in the morning, they had a fiber break, and the manager on call for that night was able to go over to his work at home desk, log in, see exactly where the break was, see exactly within 2 meters of where the break was, and then dispatch a truck specifically to that location, cutting perhaps hours out of the issue. Nobody had to go into the office to find out. Nobody had to find the Otdr meter and then go out to the COs and shoot the fiber and so forth. This told him exactly where the problem was. He sent a truck, problem solved, and you're good to go. That sort of thing can pay for this system very, very quickly. Okay, and with that, I appreciate your time and your attention. I'm going to hand it off to Greg, who will cover building the next generation CO. Thanks.
Got to remember to turn off the unmute there, Jack. Thanks very much for that. Let me just make sure that my sharing is on the right screen here. Yep, we're all set. So thanks, everybody. I know we've been chatting for a little bit here, and I appreciate that people are probably missing the time in Portland, so I made sure to put my name badge on. Steve, I apologize. I went looking, but I could not find a Head Networks lanyard, so that was the best I could do. So today, I have kind of an interesting topic, a little different than maybe other years. We're going to talk about a new product, a new element in our solution for rural and regional providers. And just to provide a little bit of context, kind of where we're going, how we got here, I want to spend a second or two just talking about context. And, you know, I love the fact that Jeff mentioned the fact that he hates the term the new normal. Actually, I hate it too. That's actually what's going to be my line when I brought up this slide. Because as much as everyone's talking about what's going on in 2020, and certainly has been unusual, the reality is that we've been preparing for a lot of what we're seeing from a work environment for a decade or more. You look on the left-hand side of the screen, you know, who among us doesn't have a few of these gadgets? And we kind of forget, a lot of these things are only 5, 6, 7 years old. I mean, 4G, which we all take for granted, except many of us who travel in the rural areas, lucky to get 1G sometimes. But 4G has only been out a decade, and of course we're already talking about 5G and 6G. Well, anyhow, the point is that a lot has changed in the last decade, and just look at how people's behavior has changed, right? You look at this graph, the quick summary on the right-hand side, the average person in the world, that's not just America, the world, spending 3 hours a day online, right? And what's interesting is 2x or 3x on mobile versus desktop. That has changed dramatically even in the last 4 or 5 years. And of course, it's only going to get to be more impressive or more change over the next decade or so. Here's one of these graphs the analyst made, which talks about the number of connected devices between now and 2030, right? And so they say today there's 20 billion connected devices, and by 2030 there'll be 500 billion, 38% change a year. Well, I don't know if that's right, but the reality is that it's going to be some number, and it's going to be a big number. So what we see happening day over day is the whole environment that we're in is changing. And Jack really pointed that out a second ago. That's one of the reasons why we have added the IP optical products into the portfolios, because we recognize your business is changing. And the big challenge that we see is that all of us, we all want the change that we saw on the first slide, right? We want our iPad, we want our thermostat that you can talk to, and all those other things. But at the same time, we'd like to figure out how to do that with a DMS TANE. But the reality is that's not going to happen, right? The problem is that all the change that we're all experiencing is changing our core business. And we recognize that. And frankly, you guys have been telling that to us over the last 4 or 5 years, right? We hear it. Kevin goes out, Jeff goes out, Jamie goes out and talks to you all. I see you all a couple times a year, either in Portland or Binghamton. And, we get it, right? Broadband a lot of times is your lead offer, not voice, right? You're under a lot of pressure in our business to adjust your OpEx because of all the cord cutting, right? You keep telling us, hey, we need more software because the timeframes against hardware obsolescence are too short. We need to be able to run stuff on anything, right? And you've also told us over and over, right, that, hey, we like the cloud content and cloud portfolios, but for our margins, because of the kind of business we are, we want to retain control. We don't want to lose control of our business just because we move our portfolio forward. So what are we doing about it? Well, we've created a new platform for rural and regional providers. And we'll talk about the fact that it's a new offer, but it's actually made up of existing ribbon elements. We're calling it Ribbon Voice Sync, so you can synchronize your network. And we'll talk in a minute about how you can integrate this into an existing environment. So what have we done? Well, we've basically created a platform and offer that encompasses billing, element management, class 4 routing and interconnect, media services and basic voicemail, SIP call control, that's SIP call control for residential and business customers, and then security, both the access side of security and the peering. And so how have we done it? Well, what we've done is we've taken a number of existing ribbon elements and we've combined them together into a single software environment, and we've taken smaller versions of these so they're cost effective for you all to use. So we're combining our application server. Now, if those of you who are less familiar with that, our AS has been around since 1999. Today it's fully virtualized and a lot different than it was in 1999, but it's built on that core level of software, right? We've got over 30 million seats of that sold. We're adding in our Sbc suite, which many of you have probably looked at one time or another. Jeff or Kevin has talked to you about that. That's our core. Sbc can scale from 1 to 75,000 sessions as a platform, fully service provider, 5 nines type product. And then we've added in our PSX. Now, some of you are familiar with that. That's our centralized routing engine that tightly couples. What's really compelling about that, and we'll talk about it in a second, is that gives you a full class 4 offer with interconnect. And then we've added to those billing and an element management system. And we're packaging all of that as virtualized software. So you'll be able to run that on the hardware platform of your choice. Now, I know this is a pretty big change, but we've put this together so that you all have another alternative from us in addition to the traditional products that your C15, your C20, and so on. We have a new product that fits into this marketplace. And we've tried to create something that has all of the feature sets that you all need, right? We understand that you have requirements for the traditional residential environment. The AS has been used for years as a class 5 feature server. I think it's about somebody like Shaw up in Canada has millions of users on class 5. Business services, for years we've used the application server. You know about our Candy business. We have a number of service providers who use it today. The application server actually runs the phone system inside the U.S. Pentagon, right? So we know how to put sophisticated business services on there, things like shared line appearances, hunt groups. Those features will all be included. And then super simple voicemail, not a complicated system. You can integrate, if you have an existing voicemail system, you'll still be able to integrate that. But this is a real basic one, ideal for residential customers, plus a built-in media server. So you'll be able to get things like tones and announcements, etc. And then, of course, if there's other things that you need, you can integrate it in, and we'll talk about some of those options, right? Now, I mentioned this a minute ago. We're including centralized policy and routing. This is our PSX. Now, why we think this is really important is this gives you an easy way to eliminate legacy TDM interconnects, right? You'll be able to go up into a network, connect all over IP. Because you have the SBC built into the solution, you automatically get a peering SBC as part of the offer. But what this also does is the PSX is a centralized routing engine. So it's going to give you a way of integrating an existing C15, an existing T7000, and third-party switches. So if you have a Meta at one of your locations, if you have a legacy BroadSoft at one of your locations, and you're thinking, so, hey, I'm not ready to make a move on those assets, no problem, right? This solution will let you bring together all of those assets and roll them into an environment where you can control them all. So if you have multiple vendors across, many of you have grown through acquisition, you picked up somebody nearby your environment, you'll be able to do that. Jamie mentioned some of the identity hub services. You'll be able to bring those in if you need to do that, right? So we're trying to create something here that's completely tied into what you all need for your environment. And we haven't really touched on price. We'll hit it earlier, but we're building this to hit your price points, right? We recognize that we have to have a solution that's cost effective at 1,000 seats. We know what you're buying today because you're acquiring C15s. This is tied directly into this marketplace. And I mentioned it earlier, we're also adding the access and peering security. So the SBC suite, it'll be available for IP peering, like I mentioned in the last slide. It'll also be available for access. So if you're in a situation where you want to, use this platform for, say, UCaaS, right? Sorry, can't get it out of my head. IP phones and soft clients. The SBC will also provide access type SBC services. You get the full security encryption, you get policy enforcement. All of that will be, again, built into the platform right from day one. And of course, because it leverages our application server, it's broadband focused. So as we talked about at the beginning of this, we recognize that that's the direction that many of you are headed. Now, you might be taking 3 years, you might be taking 5 years, it might be taking 8 years. Whatever the scenario is, this solution is designed. It's pure SIP. It's ideal for broadband. It'll work across any broadband environment. So, how you have your broadband network set up doesn't matter. As long as you can support SIP on that network, it'll work. And as I mentioned to you, we have a number of large customers who for years have been using the AS as a core platform to provide residential services across broadband. And if you don't have a broadband environment, as Jack just mentioned, we're happy to help you get into that space, right? He provided he spent a long time going into some deep details here, but it just gives you a sense for the kind of broadband capabilities we now have in the portfolio that Kevin and Jeff and Jack can help you with as you move forward. I touched on this pricing-wise. This is something that we're designing to be cost-effective at 1,000 users. Just because I know people get nervous, they see all these pieces put together, and they think, oh, these guys have, they're cooking something up for Verizon. No, this offer is directly focused on what you all do, right? And we spent a lot of time before this presentation showed up at your door today, looking at the price points, looking at the capability, and making sure that it hits the mark, right? So, easily hits the 1,000-seat environment, easy to add blocks of users in 100 user increments. So you can, if you need 5,000, you need 10,000, this solution will support that. It's no problem. Because it's virtualized software, we can basically build it as big as needed, and you're not going to impact the scalability of the solution or the capabilities. And then if you need something like, say, hey, I've got a situation where I need, I got 12 or 1,400 users, but I have some sort of sophisticated requirement for SBC. You can buy SBC capacity separately. So there's no downside here to the fact that the solution is tied together, other than it makes it easier for you all to service and support as you move forward. So why did we do this versus, what our competitors are offering? Well, fundamentally, we think that you appreciate the fact that we're still focused on this marketplace. Some of our competitors are off doing other things. We're still providing new solutions into this space. We're not walking away from what we have. We're adding to it. And we're trying to build something that's completely end-to-end. So we solve the call control problem, we solve the security problem, we solve the billing problem, and we give you a way to include robocalling if you don't already have a solution. It's all software. Now, I know people sometimes say, well, hey, I like the idea of buying everything all ready to go from Ribbon. We can still help you from a professional services perspective, build something that's perfectly tailored to your environment. We're just not requiring you to use a specific piece of our hardware, right? And at the end of the day, this is still a product that's tied into your network. You control your own destiny. So if you decide to deploy Ribbon Voice Sync, you own your margins, you own the services, you own the customers, right? So whatever you need from this solution, we can deliver it. It covers all of the bases. And with that, I'm going to wrap it up. I'm going to turn it back over to Kevin because and Jamie, because I know they're going to want to follow up on a couple of details here. And I think we have some prizes to give away too. But since you all have sat and listened for an hour and 43 minutes, we've got to give you something.
Much appreciated. Thanks, Greg. Thank you, everyone. I just sent out a question, knowing that where I live, and I just sent it out to everyone in the audience. The question was, what teams played in Super Bowl 38?
Kev, I have a question for you. Did you add the snow to the forecast tonight so people would feel like they were really in New England for tonight?
Just north of us, I think we're getting over a foot. So I'm sure nobody feels bad for us. But I threw out that question, and who played in 30, or actually, who played in Super Bowl 38?
And I guess you're looking for both teams, Kevin, right?
Yes, both teams.
One of them's probably.
One of them's who, James?
I said might be obvious, but you're looking for two.
The obvious is right. The other one has to relate to people that are on our team, just different part of the country, unfortunately for them. I just gave you a tip. But if they put it in your chat box, and that will be the first prize. Second prize.
So Kevin, people are responding in the question window, which is fine. So we do have some responses already.
I got to see that.
Go ahead and ask your second question.
My second question is, where was it played? Where was the game played? And I gave you a tip early on. It's from the state that Jamie's from. So that should be able to give you guys a tip. And I can't actually see the answers here yet, but we'll get those out.
Kevin, pull down your questions tab, and they're on there.
Okay. My fault for not being able to do that, but
I don't know why this questions tab is hard to deal with.
Oh, I see. It's the bottom here. I'm sorry. New England Patriots. Okay, that's one team. Dwayne Kosher from Empire.
I think the first answer in I see is from Rob Butler. And he said Patriots Panthers.
That is correct. I didn't see
Well, yeah, there we
that
go.
is correct. So he's a winner for sure. And my second question was Texas, Dwayne Kosher. So Dwayne is a winner and Mr. Butler is a winner. So thank you for that. Those are both correct. Those are our winners of our prizes. Just to wrap up here real briefly, just want to really thank everyone for joining and thank the Ribbon team. I think it was a great presentation. I want to thank Greg and Jamie and Jeff and Jack. I think they did a fantastic job, and thank all of you for joining. I know it's not easy doing these virtual symposiums or conferences, but we here at Ribbon very much appreciate it and look forward to seeing you all very soon. Does anyone else have anything to add?
Yep, and if you have any other questions that you didn't get a chance to ask in the chat window, feel free to reach out to Kevin, Greg, myself, Jeff, Jack. We'll be glad to get back to you on any answers that we have. So,
Jamie, do you want to walk through any of the questions that were asked there?
So I think we were able to respond to most of the questions in the chat window. Some of them I responded to just directly if it was a very specific question. The ones I thought would be useful for all of the answers, I think we did. Let me just see if I didn't miss anyone.
Jamie, I saw that. That was a good answer. I didn't cover it when I was trying to be brief, but if somebody has TDM, you can definitely use the telco bridges to integrate traditional environments with the new voice sync platform. So even though it's native SIP end-to-end, you definitely could do that. Plus, because of the way we've got the centralized routing engine in there, if you have an existing TDM platform, ours or somebody else's, you could still bring that in via SIP trunks, so the whole thing would be connected.
Yep, exactly.
Not as much fun as the football questions, but still relevant.
Yep. All right. Well, thanks again, everybody. And
thank you very much. Thank you, TANE Symposium, the folks at TANE for putting this on. I think it was a great success. Have a good day, everybody. Be well now.